sigma and pi bonds, examples of sigma and pi bonds, and how to find sigma and pi bonds. Firstly, let me teach you the concept of overlapping. Consider these two pencils. We know that this is the head of a pencil and this is the side of a pencil. Now I am interested to join these two pencils together. Can you guess the possible combinations? Well, there are several combinations possible. But here I only discuss two types of combinations. For example, head-to-head combination and side-to-side combination. For instance, when the head of this pencil is joined with the head of this pencil, it is called head-to-head combination. Secondly, when the side of this pencil is attached to the side of this pencil, it is called side-to-side combination. This is the core concept of sigma and pi bonds. Therefore, note it down. Now, what are sigma bond and pi bond? Well, the axial overlapping of atomic orbitals form a sigma bond. Axial overlapping is also known as head-to-head overlapping. For example, consider these two p orbitals. This is the head of this p orbital and this is the head of this p orbital. When they both overlap headwise, it is called head-to-head overlapping. As a result, they form sigma bond. While the parallel overlapping of atomic orbitals always form pi bond. Parallel overlapping of atomic orbital is also known as side-to-side overlapping. For example, consider these two p orbitals. This is the side of this p orbital and this is the side of this p orbital. When they overlap sidewise, it is called as side-to-side overlapping. Thus note it down that head-to-head overlapping of atomic orbitals always generate sigma bond, like in this example, while side-to-side overlapping of atomic orbitals always generate pi bond, like in this example. Now, what are the possible combinations of atomic orbitals that form sigma bond and pi bond? Well, we know that head-to-head overlapping of atomic orbitals always form sigma bond, and side-to-side overlapping of atomic orbitals always form pi bond. For example, s orbital plus s orbital always overlap headwise to form sigma bond. Secondly, s orbital and p orbital always overlap headwise to form sigma bond. In case of pp overlapping, it may either form sigma bond or pi bond depending upon its overlapping. For instance, if p orbital overlap headwise, it will form sigma bond. If p orbitals overlap sidewise, they will form pi bond. Thus, only sidewise overlapping of p orbitals form pi bond, while headwise overlapping of ss, sp, pp orbitals form sigma bonds. Also, you should learn that why we study sigma and pi bonds. Well, sigma and pi bonds explain the bond energy, bond strength, and bond length of a molecule. For example, consider sigma bond between these two p orbitals and pi bond between these two p orbitals. Remember that there is always maximum overlapping taking place in sigma bond, while there is always minimum overlapping taking place in pi bond. Also, according to valence bond theory, extent of degree of overlapping decides the bond strength, bond energy, and bond length. So we therefore say that sigma bond is stronger than pi bond. Secondly, the maximum the overlapping between two orbitals, the greater will be the bond strength or bond energy. While minimum the overlapping between two orbitals, the smaller will be the bond strength or bond energy. Also, let me teach you the bond strength, bond energy, and different combinations of atomic orbitals. For example, in head-to-head overlapping of two p orbitals or sigma bond between two orbitals, there is maximum overlapping. So it forms strongest bond, or it has high bond strength or high bond energy. Secondly, the sigma bond of sp orbital also have greater bond energy but lesser than pp overlapping. Thirdly, the sigma bond of SS orbital has lesser bond energy than sp overlapping. And finally, the pi bond of pp orbital has smallest bond energy because the extent of overlapping between them is smaller. Now remember that the higher the bond energy or the bond strength, the smaller will be the bond length. For example, in case of sigma bond of pp orbitals, there is high overlapping, hence both the p orbitals are close to each other and the bond length is smaller. While in the case of pi bond of pp orbitals, both the p orbitals are away from each other and the bond length is greater. So this is the order of bond energy. Here, let me teach you one bonus MCQs. Which bond has more bond energy or bond strength? 1s2s, 1s2p and 1s3s. Well, the answer is 1s2s because 1s and 2s are close to each other, so the extent of overlapping between them will be maximum and they will form strong bond, but its bond length will be minimum. While 1s3s are away from each other, so the extent of overlapping will be minimum and its bond energy will be smaller, but its bond length will be greater. Therefore, we study sigma and pi bonds because they teach us about bond strength, bond energy and bond length of any molecule. Finally, let me teach you that how you find the number of sigma and pi bonds in a molecule. Remember that the first bond between any two atoms will be sigma. It is impossible that the first bond between any two atoms would be pi. The second and third bonds between them will be pi. For example, find the number of sigma and pi bonds in water H2O, ethene C2H4, ethine C2H2, propanic acid C3H5OH and sulfur trioxide SO3. Well, in case of water, oxygen forms single bond with this hydrogen, so it is sigma bond. Oxygen also forms single bond with this hydrogen atom, so it is also sigma bond. Thus, there are two sigma bonds present in water, while there is no pi bond present in water. In case of ethene, carbon forms sigma bond with this hydrogen atom, carbon forms sigma bond with this hydrogen atom. The first bond between carbon-carbon is sigma bond. The second bond between carbon-carbon is pi bond. This is also sigma bond. This is also sigma bond. So there are 5 sigma bonds and 1 pi bond present in ethene. In case of ethine, this is sigma bond. The first carbon-carbon bond is sigma. The second bond between carbon-carbon is pi. The third is also pi. And this is also sigma bond. So there are 3 sigma bonds and 2 pi bonds present in ethine. In case of propanoic acid, all the single bonds are sigma bonds, while the first bond between carbon and oxygen is sigma and the second bond is pi. So there are 10 sigma bonds and 1 pi bonds present in propanoic acid. Therefore, remember that first bond between any two atoms must be sigma, while the second and third bond between them would be pi. Thus, by this way, we can easily find the number of pi and sigma bonds in any molecule. This was all about sigma and pi bonds.